Hey everyone, and a warm welcome back to our ongoing series of Docker tutorials. In today's session, we will be talking about Docker Compose. More specifically, we'll be focusing on the use of variables in Docker Compose, which will allow us to simplify the configuration of our containerized applications. By leveraging variables, we can easily modify and customize different aspects of our Docker Compose file, such as container names, port mappings, and environment variables without the need for manual editing. This can greatly enhance the flexibility and maintainability of our Docker-based applications and enable us to achieve greater efficiency and productivity in our development workflow. So sit tight and get ready to explore more on Docker Compose. As we know, Docker Compose is a powerful tool for defining and running multi-container Docker applications. It allows us to use a YAML file to configure all our services, networks, and volumes required for our application stack. If you need a recap on Docker Compose, please check out our YouTube video specifically dedicated to this. All right, let's see how we can create an API that can handle CRUD, which stands for Create, Read, Update, and Delete operations for interacting with our PostgreSQL database. For that, we'll use the Flask framework in Python. As you probably know, Flask is a popular web development framework that provides developers with a simple but flexible way of building web applications. So by using Flask, we can easily create these endpoints that can be used to interact with our database and perform the necessary CRUD operations. These endpoints can then be accessed by other applications if you may want to use that more in the future, allowing them to interact with our database in a secure and controlled way. All right, let's get started by going to our GitHub repository. So we've already created previously the code for you, so we can speed this up. However, we will go and run through the code together just so we can also bring you up to speed for this demo. Don't worry about the link. We will provide it in the link below. So the repository itself is called YouTube Docker Compose with variables. And in here, you'll be able to find a brief description of what exactly this exercise is consisted of. So as previously mentioned, we will be playing with Flask CRUD API using Docker Compose variables. So we'll be building a Flask application and also be interacting with PostgreSQL database. You can also read here a brief introduction and also all the contents. So the app.python file containing all the code necessary to build up the app. We've then included the .env file, which will be used for environment variables, where we're going to store in this specific file for configuring our Flask application. We will also be using requirements.txt, so obviously listing all the required dependencies for our application. Dockerfile to build the customized Flask app for ourselves. And lastly, Docker Compose file, so a single YAML file where we're going to specify our configuration to set up all the services required and to also get them started. So in here, we've also included the command we're going to be running to spin this up, and some testing steps, which will be quite fun and interactive, also that you can use for other purposes in the future. Okay, now that we've been through the description, let's go to clone this Git repository down to our local machine. So just to give you a quick demo or a preview of where I currently am. So this is just a folder we're using for testing purposes. So in here, we will do git clone and then paste in there the actual URI to our Git repository. And we'll be able to see our Git repo that we've just cloned down. So let's just make sure we are in the right place. And we're using Visual Studio Code for this demo just because it's really easy to navigate through all the necessary files and also at the same time using the terminal availability, the feature itself. So let's have a quick look into the actual files. So we'll probably start with checking through the requirements .txt file. So once again, these are all the dependencies that we will use, of course, to get our Python application installed successfully and running. So the first one, Flask, is just a lightweight web framework for Python. It basically allows you to build web applications easily in the most effective way. The second one is mainly used for PostgreSQL as an adapter for Python, and it allows Python code to interact with the Postgres databases. And the last one is an extension for Flask that adds support for the SQL Alchemy, which is basically an SQL toolkit, and the ORM, so Object Relational Mapping library for Python. Pretty much in summary, it simplifies the database operations by providing an abstract interface to allow us to interact with databases using the Python objects. Next in line, let's just exit this terminal to expand on our application. Don't worry, we're just going to be using this as for testing purposes. We'll also give you a brief preview of what exactly we are going to be doing or we have included in this code. So the first import section, so we are listing all the necessary modules for Flask and SQL Alchemy in the top one, as well as the environments, which is something we're going to be using later on. Application initialization. So we will start by initializing our Flask application. Here we've also set our database configuration. So the URI for basically our database, which is just over here. And basically the URI is stored in an environment variable, which we called db_URL. And it should contain the connection information for our database. So if we take a quick look at this environment file in here, we can see our variable db_URL and the actual URI to our database. It is consisted of the user password, which we're just using for demonstrational purposes, Flask_DB with the port number, which is standard for Postgres here at the end. Going back to the app.py file, we have also defined a model in here using the SQL Alchemy ORM, which technically represents a user in our application and maps them to the correct table using the Headintheclouds _users in the database. And in here we can see that it has got 4 attributes, so ID, username, email, and age, just for the testing purposes. Here we have also specified to create a database, so it is really important to create the necessary database tables based on the defined models using the db create all. And here we have added some routes. So we started with Headintheclouds test route. So a very, very kind of basic app routes, which if you obviously type localhost with the port number where we're going to be running our application, and then /hello, the message in return should be this one here, with obviously confirmation code successful 200. We have also created another additional route, which will be post to create, to allow us to create a new user. So in here you can also see some specifications where we can determine username, email, age again, and some of the responses that we might get back in return, depending on the success, of course, of the deployment as well. So everything goes well, we should be getting to 101 as a confirmation user successfully created. Or if we encounter any errors, in that case, we will see the error 500. Something went wrong while creating a user, so we'll probably have to do some additional troubleshooting. We have then created a route to list all users or get all users using the method of get. In here we do have a couple of more responses for confirmation of successful fetch of the users, and again in case of an error to display us again 500. We have then created something similar for getting a user by ID, which will be quite fun also to play with. We have also used the put, which will basically allow us to update a user based on the ID, which is quite handy also to have in case you do want to interact even more with your database and all the information that's been created in there. And lastly, in order to clean up or delete certain users, we have also created that as well as last part of this exercise. Next, we will be moving on to the Docker file. So in here, we've added some comments just to give you a walkthrough what exactly is going to be happening. So as you can see at the top, we're using Python 3.9.10 Slim version as a starting point. And we're also setting our working directory inside the container to app directory. We're copying the list of required Python packages. So everything from the requirements.txt will be going in there onto the container. We are then installing the Python packages listed in the requirements, and also ensuring that the Python.env package is also installed to manage our environment's variables. We will then proceed by copying all of the project files into the app directory that we set in here previously on the container. We'll be exposing port 3000 to allow all the external connections. And lastly, we'll be starting our Flask application and making it accessible from all network interfaces by listing host to 0.0.0 and also using the port 3000 as we've mentioned previously. This is just for testing purposes, so we're going to be using this method only in the dev environment. Lastly, we will go through the Docker Compose file. So in here, we'll be able to see a couple of services that will be running. So we've got Flask app. We've also called the container the same way. We've created the image called Headintheclouds online, and then Flask CRUD API version 1. We have also added the command builds. So once we run Docker Compose, it will also build this image for us as part of the execution. We also have the ports, as you can recall it previously. So once we build the image for our web application, we are exposing it on port 3000, and we also need to make sure it's been equally defined in this Docker Compose file. Environments, db underscore URL, we have specified in our environments file, so we'll be collecting that from there. And then moving forward onto basically depends on is added in here just because in case the actual Docker Compose is run, we need to make sure that the Flask application is running, but also that the Flask_DB or our DB container is also up and running, because the application will have dependency on it. Otherwise, it will just fail. Under the second service, so another container, we've got Postgres. As we said, we're going to be using it for this purposes. We've also added the ports numbers, so please do get yourself familiar just with some standards. So for Postgres, we are using 5432. Will be quite handy for you to memorize that for future exercises. And here in environments, we just want to give you an example of how it would look like if, without using the actual variables. So as you can see, we'll be directly exposing the credentials, the username, password, DB information into our file. Will be hard-coded, and this is not a preferred, of course, option, best practices, or for security reasons. So we are instead going to be using variables, again, linked to all the information in here that we have previously provided in the environment file. And lastly, we're going to be creating a volume where we're going to be storing all our, let's say, data the Postgres onto that volume. So even if Docker Compose or the Docker containers get stopped next time when we do bring them back up, with this volume already being created with Docker, we can just pretty much attach our containers to the volume and still have that information accessible to us. So it's really, really good for reliability. Now let's reflect briefly on this .environment file. There are actually two ways of how we can approach this. So the first one is either as by defining the variables in this file, which makes it easier to manage environment-specific configuration values and to separate them out from the actual application code itself, as we've seen it over here. So the advantages for this is pretty much having a centralized configuration approach. So having all the environment variables stored in a single file, which will make it easier to manage and track, of course, configuration changes in the future. Also, if you have environment-specific configuration, it will allow you to define different values for variables in different environments, such as dev, staging, production, etc. So by maintaining separate environment files for each one of those environments. Of course, version control, these files can be versioned along with the rest of your project code, which will give a record of configuration changes over time. And of course, for security purposes, it's always preferred to store your information or sensitive data separate, not hard-coded in your application code, but more kind of defined in variables. The second approach will be pretty much using the shell environments. So if you were to, let's say, define a variable of DB URL, and then we can do also echo on DB URL. In here, you'll be able to see that we have specified, defined our DB URL variable locally. So if we were to remove this environment file when we are running Docker Compose, then it will be picking up the locally defined variables instead. So it's just a matter of different approaches. This method will probably allow you a little bit of flexibility and adaptability in the configuration process. Some of the advantages is obviously dynamic configuration, so you can make the changes on the go by setting up your environment variables directly in the shell environments. And you can also see the immediate effects, so changes that you're making to your environment's variables will take effect pretty much instantly without the need to modify or reload any of the files. But as you can imagine, disadvantages are, of course, lack of centralization. So, if you're working with environment variables and you would like to set them in the shell environments, they might not be as organized or easily managed as those defined in the centralized environments file, and also can't be easily shared with other team members, of course, if they want to work on the same set of applications. And of course, environment dependency, it would rely heavily on the shell environments of your local system where you'll be running Docker Compose, which may differ between development machines and deployment environments. All right, let's see this in action now. So I'll start by running the Docker Compose command that will pretty much build the Docker image for our Flask application service, previously defined in our Docker Compose file. And then we will start the containers for that service, ensuring that any changes in our application code are reflected in the Docker image and containers. So we will type Docker Compose up, and then we'll specify -- build, and then we will call our service. So the name of the service will be Flask app. And it will start the building process. As you can see, there's quite a few things to go through. So as we're doing this for the first time, for this demonstrational purposes on our local machine, we'll just allow it to do its thing until it's completed. As of course it's running first time, it'll probably take a few minutes, but we'll be able to carry on once that's in place. Now we can see the building process of our image. So it's going through different stages of building our Flask application by pulling the Python image and going through all the configuration setup that we've previously specified in our Docker file. And lastly, we can see the network has been created. So as we mentioned in our previous video, this prefix is just using the name of our container, so YouTube Docker Compose variables, and it's calling it or giving it name default because we haven't specified any sort of network configuration in our Docker Compose. We can also see the volume being created for our PostgreSQL, as well as the containers for database itself and the application. And in here, because we're not running the Docker Compose command in detached mode, just for the sake of actually getting some logs, as well as we're doing some interactions and testings of our Flask CRUD API. So let's go back to our internet browser. And in here, we will type in localhost 3000, and we will also specify hello, which will be coming from, as if you can remember, in here we specify our first route to be test of the connection. So if we go to /hello, we should be able to see this message in our internet browser. As you can see, that's been successfully demonstrated. So this is exactly what we're getting or expecting to get in return. And also, if we check our logs in here, we'll be able to see HTTP 200, which is obviously what we were expecting to see as the successful confirmation of our connection being established between the actual API and the database. Next, we will be going through our list of users. As we haven't created anything just yet, we will just use this to quickly show to you the message that we've specified again in the app.py application code. So under here, you'll be able to see the app route to users, and if the message is successful, we should get this in return: all users fetch successfully. And we can also see that in here with the code HTTP status to 100. And again, we can see here in our logs get users, which is exactly what we did. We were listing all our users using get / users, and also seeing the successful connection to that route at the same time. Now, to make this exercise a little bit more interactive and fun, we'll definitely highly recommend to you to refer back to our Git repository. In there, you'll be able to see some steps on how to get Postman installed on your local machine. You can also use it through web UI as you prefer. But as you'll be doing some local tests, make sure that you're running Postman agent as well on your local machine if you were to use the web UI version. Postman is really, really popular, really handy to test all the HTTP requests and to review this in a more kind of user-friendly way. And you can use Postman to test all the CRUD operations that our Flask API endpoints are there to offer to us. So please do go for the installation from their official website, and we'll also demonstrate in this video how to interact with it at the same time. So without further ado, let's go to Postman. In here, we've created just a workspace which we'll be using for testing purposes. And then here we'll click on New HTTP, and then we will specify the same as we previously run in our internet browser. So if we do port 3000, hello, and then we can do send. And in here you will also be able to see the same message as we were getting in our internet browser, which is, hey there, welcome to Headintheclouds. So really good to test all the HTTP requests, of course, that we can play with as part of this exercise. In here, you can see other methods that we will definitely be using, such as post, put, patch, delete, and so on. So let's carry on with some other demonstrations. To be able to get a list of all users, we will run this with get. And as you can see, we haven't created any users just yet, but we can see that we can successfully reach that endpoint. And if we go back to our logs, we can also see all the good, successful attempts in our logs as well. To be able to create a new user, we will do change this to post. So if we go back to our code, so create a user, we'll be looking at this endpoint here. So we'll be reflecting the same. So using post local host 3000, and then again specifying users to be able to create that. And then here we'll go and switch to body and then specify raw. We'll open curly brackets, and if we go back to our code again in here, we've got to username, email, and age to supply basically as part of this exercise. So we'll do in quotation username, let's say test user. And we've also got email, and that will be, let's say, test at gmail.com. I've also forgot to put comma here, the same as here. And lastly, we'll do age, and then let's say 28. And here you can also see what are the expected responses to get. If it's been obviously successfully completed, then we'll get user successfully created with the code 201. Or if it fails to create a user, then it will tell us that something went wrong while creating that user with the error code of 500. So let's see how this goes. We will click on send, and we can see in this section here the message stating that the user has indeed been successfully created. We can also see the status here of 201, which means that the request has been fulfilled and resulted in a new resource being created. So really handy to also use that as your troubleshooting exercise. And the same confirmation in our log file, we can see that now we're using post instead of get to create a new user, and of course we're getting the expected HTTP status of 201 as well. We can then create a couple of more users, so we'll still remain in using post and then localhost 3000s with /users. We just need to modify this specifications of the username, email address, and age, and then we'll run again, and it will be added on top of our previously created user. You'll also be able to see the IDs specifically assigned to those users when we do get users again, which we'll demonstrate in a second. So I'll just use my name, and same in here, and I'll put my age here as well. If we do send, and another confirmation message telling us we've been doing this or created it successfully with the 201 code, and also the same in our log files, which is absolutely great. And if we switch this back to get to list all of our users again, so we are using get method /users. If we send that in here, we'll be able to see the confirmation message of all the users being fetched successfully. And then the first one we created was a test user, so we can see the ID being assigned 1, and then the second user that I've just created now, which is assigned under ID number 2. So let's create maybe another user. We'll call it Anna as my co-partner, and let's put her age in here. And if we do the send again, we can see that the user has been created successfully again, and let's switch back to get, and as you can see, the third user with the ID number 3 has been added in here successfully. To continue moving forward, we would like to now test how we can get users by specifying their ID. So we want to list a specific user, let's say Millie, and we can do that by doing users /2. And if we click on send, we should just be able to see a user with ID number 2. And if you do 1, you can see that it's our test user, the first one we created, and 3, which will be the last one we've just created. We can also update a user. So if we go back to our code and look at the root under this comment, update a user by ID, we need to specify the user and the actual integer or the number of the ID, so the user. And we're going to be using this time method put, which will be updating information as we go. So let's switch that to put. And then in here, we're going to specify, let's say, user 1. And we'll again use this just to update previous information. So if you just need to kind of use that as a reference, you can also list all the users again. And then you can do put users and then specify, let's say we want to change the first one, user number 1. And in here, we will change that to, let's say, head in the clouds. And we can also use our official email address, which will be head in the clouds line. And we can leave the same age. And if we do send, we can see that our user details have been successfully updated. We're also seeing the status code of 200, also a brief description of what exactly it means. So it's a standard response for successful HTTP requests. If we go back to our code, we can also see code 200 for our put request, and we're looking pretty good at the moment. If I go and list all the users again, you'll be able to see as we've modified this first user, with the ID number 1. It's just showing us here at the bottom with all the information we've previously provided in there, so it is up to date. Lastly, we will do the exercise of deleting users. So let's go through our final route. In here, we'll be able to see defining again users and then specifying their ID and then using a method delete. So let's do that. Users, and then let's do user number 1. User has been successfully deleted. We can see code 200, the same in here with the delete method. And let's get the list of all our users right now. As you can see, we can only see 2 of them at the moment in here. Lastly, we would like to show you how to use Table Plus. Again, if you haven't used it before or downloaded it on your local machine, you can find all the necessary information here. It is, again, really popular tool to use to have a clean user interface of managing your databases. You can use this tool to interact with all the databases associated with our Flask API. So please, highly recommend it. Go through the installation processes, and we will shortly show you how to also use this on your local machine. So I'm going to search for Table Plus, and in here we will create a new connection. So we'll use PostgreSQL as that's what we're using for this demo. And in here, we're going to put localhost, and it's already giving you a suggestion 5432, which is the port for Postgres. Username, password, and database. You will be able to find that in the environments file itself. So username will be this one, and then we'll go for our password and the database name. And if we do test, you will be able to see a green confirmation that's been successfully tested or communicated to our database. And let's click on connect, and this symbol here, which will open the database, and we'll go straight to the Postgres. In here, we'll be able to see our table that we've created previously. So if we go back to our Python code, you can see that's been reflected over here. And as we have previously created a couple of users, and here you can see Millie user and Anna user. We have deleted user with ID number 1. So you can also do some interactions through this tool directly itself. You can also, let's say, create a new user. Let's call it new user, new, and let's give it 30. And if we save that, you can see here it's been confirmed. And go back to our Postman and list all our users again. At the bottom here, you'll be able to see newly created user and also a confirmation in our logs, which is just relevant to what we are seeing here as well. And you can also go ahead and let's say delete this raw. If you save it again, you'll see some updates in here. And if we refresh this, then we're back to having only 2 users, which is what we expected. And lastly, once we are done with all the testings, we will stop this containers that we've previously started with Docker Compose. We'll give it a minute or two to gracefully stop all the previously started processes. We can do Docker PSA because we've just run or exited the run that we previously started. We haven't deleted the actual containers just yet. They're just in the exited or stop state. So in order to make sure that we do a proper cleanup, we will type this command docker compose down, and you can see now it has removed the Flask application itself, the database and the network that's been previously created. So if we do Docker PSA, there's nothing to be found in there. Here we can still see our images, but you can also do a cleanup as we don't have any containers at the moment being in use. You can just run this commands to do the tidy up on your local machine, and you can also do the same for volumes. So docker remove, and then let's just get rid of this. Docker volume remove. And that's pretty much it. So we're good to conclude this hands-on session. Thank you for watching our Docker Compose with variables tutorial. We really hope it was helpful to you. We will be creating more tutorials in the future in the fields of DevOps, web development, software engineering, cloud computing, and so on. So please stay tuned for more updates. If you enjoyed this tutorial, please consider liking and sharing it with others who may also find it useful. Once again, thank you for your support in our journey, and we look forward to seeing you in our next video.